Okay, so let's just go ahead and get going. You were saying that you were having trouble with, let me look it up again. Okay, you're having trouble with equations of circles without coordinates, independent events, dependent events, conditional probability. Okay, let's start at the beginning. So you were talking about, crap, I forgot already. Oh, equations of circles. Oh, all right, hang on. So I'm going to share my screen here. So you should be able to see what I'm seeing. Hopefully you're seeing like all of it. You should be able to see everything. So I got this part over here too. I'm going to send you all these over here. These are worksheets that I have with the answers already on them. And we're just going to go through them real quick. But this is just like to front load a little bit, you know. I mean, shoot, maybe this will do it for you. Who knew? Who knows? Anyways, all right. So equations of circles. So what you have to know is equations of circles come from the distance formula. The distance formula, now, all right, look, I'm writing with a mouse here, so it's going to look like crap. So whatevs. But it comes from the distance formula. So it's going to be the distance equals the square root of the difference in x's squared plus the difference in y squared. And all that comes from Pythagorean theorem. But anyways, what we're doing here is we are looking at x minus h squared plus y minus k squared equals r squared. Okay, where r squared is your radius and these are your points. Points of the center, I should say. If we're looking like over here, where is, okay, right here. The equation of a circle with center hk. So h is our center, is our x coordinate, and k is our y coordinate. So this actually looks like this. Like x, y is actually h, k. I know it looks like crap, but you have to deal. Okay, so one thing to notice that in the equation here, it has a minus. Okay, so what I mean by that is if the equation is a plus, so if it's like this, x plus 2, like right here, then you know that our point is actually, h is actually negative 2. Because in order for because the equation is negative, so in order to make this positive, this has to be negative. Because negative 2, if I put negative 2 right in here, if I put negative 2 right in there, it's going to be a negative times a negative equals a positive. Okay, that's like the biggest thing people screw up on right there. So I don't know, maybe that did it. Who knows? But anyways, let's just keep going. Like yeah, let's just keep going. Alrighty, let me do like 1 or 2, and we'll. Man, this eraser sucks. Okay, yeah, let's do a couple from there. All right. Okay, so let's look at this one here. So write the equation of a circle. Let's do this one. Okay, so center is at -2, 3, and the radius is 5. Okay, so -2, 3, and the radius is 5. So we know that this is h, we know this is k, and our radius is 5. Okay, so let's write our formula. X minus h squared plus y minus k squared equals r squared. Okay, so let's go ahead and put it in. So we know from what we were doing up here, that this is h and k. All right, so the first one's h, the second one's k. Now, in order to make this negative, remember we have to think in opposites. In order for this to be negative, then up here it's going to have to be positive. Because when we plug it in, it's not going to be the -2 again. So this is actually going to be x plus 2 squared plus y. Now, our k is 3, so we're doing the opposite. So instead of positive 3, it's going to be negative 3 squared. Now our radius is, or we know our r is, I shouldn't have drawn that. We know our radius is 5. So our r is 5, because we bring down the squared now. Now 5 squared is going to be 25. And that's our answer. Okay, so if you look up here, and yeah, we got that right. Okay, so when you're plugging in the h and the k, always go to the opposites with the h and the k, and then your radius, it's usually, if it tells you the radius, then it's doubled. If it gives you the equation, then it's cut in half. But not cut in half, I'm sorry, squared. But usually it's going to be doubled. I mean, you don't really have to go through too much from that. So, all right. Yeah, so those aren't too bad once you get the structure right. And, oh, this eraser's killing me. Can't you go like a little bit faster, dude? You know what? Okay, I'll just rewrite it. All right. So let's try like, I don't know. Let's see. So you can, I'm sure you can draw them. And what was it? Writing the equation of a circle with no equation or something, with and without equations. Is that what the other one? Without coordinates. Okay. So without coordinates. Okay. So you're looking at just a circle then. Okay. So you probably have something like, let's just say you have something like this. Okay. Yeah, let's just say you have that. Okay. And let's say you have, oh man, that's bad. Oh my gosh. Okay. I wonder if there's a shape thing here. And there's not. Okay. Anyway, it doesn't matter. We'll have to deal. Okay. So let's say there's the center of the circle. And so go 1, 2, 3. Let's go here. 1, 2, 3. Again, I'm doing with this mouse, so it's going to look pretty crappy. 1, 2, 3. 1, 2, 3. Okay. Man, that's a bad circle. Okay. All right. So anyways, so let's write the equation of this circle. All right. First of all, let's write the equation of our just our random, not our random, but our generic equation of the circle. We start with our x's. You know that, Adam. Okay. So it's going to be x minus h squared plus y minus k squared equals r squared. Okay, and then remember h and k are the center point here, and they're opposites. Okay, so this is going to be, let's see, all right. So let's go ahead and rewrite what we need to. Because sometimes in math, even if you don't really know the answer, as long as you just keep kind of walking in that direction, it'll come up, like the answer will be revealed, as they say. Okay, so our x coordinate. Our x, remember, is our h. And we are, here's the center, kind of. So it's going to be like 1, 2. So this is going to be 2. And remember, it's opposite. So it's going to be, let's see. So if we put in -2, and we want it +2, so it's going to be -2. Okay. And remember, because we're putting in opposites. Okay. All right. And then our y. How many up do we go? We go 1, we go 2 up. Okay, I didn't mean to go 2s and 2s, but that's what we're doing. So we're going up 2, and we're putting in opposites, so we put in -2. Okay. All right, and then what's our radius? So we start here, and we count along like the crosshair. So we go 1, 2, 3. We know our radius is 3. and we bring down the squared. So that's pretty much it. The only difference is they might want you to change this to like this right here, y plus, I always want to write pluses, minus 2 equals 9. They might want you to write it like that. And that was just from here to here. That's all that was. But just remember, the hardest part with this thing is remember that we're always putting in opposites. And once you have that, then it's no big deal, man. So not too bad. Not too bad. Okay. Let's jump right here to our next part. And the next part you were asking about was conditional probability. Independent and dependent. Was it independent, dependent? Conditional probability. Independent events. Okay, let's see. Let's just make sure it wasn't this one. Okay, maybe it was this one here. All right. So independent and dependent events. An independent event is something or two events that doesn't have anything to do with the next event. So like, for example, what's the probability that I flip a coin and get heads, and that I roll a die and get 5? Well, one probability doesn't have anything to do with the other probability. Okay, so when I flip a coin, whether I get heads or tails, that makes no difference on whether I roll a 5 on that die. Okay, that heads or tails, it doesn't matter. Okay, so that's independent. It means one thing has no bearing on the other. A dependent probability would be one thing, the first thing affects the second thing from happening. So like, for example, if I say, what is the probability of me having an umbrella given that it's raining outside? Well, okay, well, yeah, well, given that it's raining affects the probability I'm going to have an umbrella. Okay, so those are dependent. Or they always say, like, with replacement, like they like to use cards or marbles. So like if I say, what is the probability that I pick, let me write it down. What is the probability that I pick 2 kings out of a deck of cards? How about this? What is the probability that I choose a king out of the deck of cards, and then I choose another king? We'll say that. So without replacement means I don't put the card back. So we know there's 52 cards in a deck. Okay. Probability is always what you want, your outcome, over your total possible outcomes. I have no idea how to spell possible. You know what? It doesn't matter. But your outcome over everything. So your desired outcome over all of them. So you know what? Let's just erase that. I know I spelled it wrong. I don't care. Okay. So first of all, there's 4 kings in a deck. So when you first do it, it's going to be 4 out of 52. Okay. But things change. Okay. Because by the second time you do it, number one, you don't have 4 kings in there anymore because you didn't put that card back, and you don't even have 52 cards anymore. Okay. So this is going to be, the first king is going to be 4 out of 52 because there's 4 kings in the deck, but you throw that card away. It's gone. Okay. It's fiction now. So now you do 3 kings out of 51 cards because you have 1 less king and 1 less card. Okay. So those are dependent events because what you do, the first one depends on, what you do. Your first one makes a difference out of your second, or your second makes a difference out of your first. So they interfere with each other. Okay. So on independent events, when you're doing conditional probability or something like that, when you're doing this kind of compound events, compound simple events, you just multiply them together. So 4 times 3 is 12, and 52 times 51 is, geez, I don't know, 250 or something, something like that. 52 times 51. Oh, shoot. 2652. 2650. Ooh, that looks bad. 2652. That's your answer. You just multiply them together. So if you look at them up here, it says probability of independent events. Probability of A and B is A times B. And the probability of dependent events is the same thing. It's still A times B, but it's probability of B following A. So that's what we did right here. We did probability of A, which is a king, is 4 kings out of 52 cards, times B following A means the probability changed. So now there's only 3 kings and there's 51 cards, and that's how we got that. Okay, and it's going to give, yeah, see, here's that marbles thing I was talking about. See, 4 marbles, 5 blue marbles, 3 purple marbles, and it tells you, it gets them all screwed up, and it's telling you, you know, what's one given the other. But that's all that is. It's just not, it's not too difficult. I'm going to send you them all, but I'll send you this for now just to kind of show you, you know, a little bit of a little preview, I guess. And I don't know, maybe that was all you needed. Who knows? Let me know. Peace.